girls? All right, so first thing we're going to write down is when we've got this, it looks like it's saying fog. It's not really, and I got to say, I'm not a massive fan of this notation at all, and it was when we just amalgamated with the eastern states, they brought this in. For me, as soon as I write this down, or see that, the first thing I do is I rewrite it to be that. Okay, and then this is now stuff that we should know, because f, Archie, we right? F is just a function. This is saying g of x, that is then another function. So your typical scenario will be, we might have f of x, and we could have, it could be a quadratic, it could be linear, it could be cubic. We're going to keep it nice and simple this morning. So let's have it as minus 2x plus lucky 7. And g of x, what would we like that to be? 6x take 3. Happy? Keep it simple. So, what we know, and what a good mathematician will do, Hamish, is that when we see this, we go, well, what could we do? Well, the first thing we can do is go, well, hang on, I know what g of x is, do we not? What is g of x? 6x take 3. So I put that there. And now, what started as a whole lot of letters and brackets and blah, we now go, oh, well, I know what that's telling me to do, is it not? Because last couple of lessons ago, when I said f of 2, you know that's me asking you to do what? Sub, go back to your f function, and wherever x is, replace it with 2. Well, this is now saying, go to your f function, and wherever x is, replace it with So it's going to be minus 2 instead of times x. What is my x? 6x minus 3. And don't forget, you have to still plus 7. Yeah, probably would have been better because I'm just doing what some of the book does. If they'd sort of said 6a take 3, it makes it not so many x's, but some people would go, no more letters. Anyway, we now simplify. Minus 12x, minus and a minus is a plus, so we get minus 12x plus 13. Agreed? Most of your mathematical life you have been taught 3 times 2 is the same as 2 times 3, so AB is the same as BA. So what do we think? F of g of x, do we think that is the same as g of f of x, do we? We think not. Wise people. So this now becomes g of, what's our f of, I'll write it properly, g of f of x. And what is our f of x? Minus 2x plus 7. I mean, there are instances where they do equal each other. Maybe it's not this case, but anyway. Oops, I need my G. Okay, so again, if you understand clearly that what the notation is telling you to do, this is a piece of pie. Go to your G function, and wherever x is, replace it with that. Might even highlight it for you. So that is going to go there. Do we agree? So 6 times minus 2x plus 7. Go back to your G to see if there's anything else that you need to do. Yes, we have to take 3. And now tidy up. Minus 12x plus, 42. Definitely not going to be the same as the other one. Got the same x but not the same constant term. Huzzah. Sweet. We're going through our example. So again, we're going to write g, f, now of minus 1. So we go, that's okay. This is actually just going to be the same as g of f of minus 1. How am I going to find f of minus 1? What is that telling you to do? Sub into where? F. So go to your f function here, and we're going to replace x with minus 1. Now, up to you. You might want to do it to the side, and so say f of minus 1 is minus 6 take 5, so we get minus 11. Huzzah? So that means we're finding g now of minus 11. We'll do that again. They said they're lost. We'll do that. So you can do that because I've done it to the side, or g of f of minus 1, that equals g of minus 6 take 5, which equals g of minus 11. We get to the same point. Which one mushes with you? You said go. Go to your g function, and wherever x is, we're now going to replace it with minus 11. So instead of x squared, it's going to be minus 11 squared plus minus 11. So I'm just going to say minus 11. So 121, take 11, I get 110. I said 110, but I wrote 120. We've got f of 0. That equals f of 0. Boy, oh. A lot of f's there. There's even an off backwards. Be careful. So, first thing we're going to do is we look inside the bracket. Can we figure out what f of 0 is? Yes, we can. It's saying go to our f function. Wherever x is, we're going to replace it with 0. I'm hoping we don't have to do this to the side. Because what's f of 0? Minus 5. So this now becomes, still got that f there, f of 0 is minus 5. Got to be really careful with your writing and your notation. If you are, this will not be a problem. If you're messy, good luck. Not happy with it yet, are you? We'll get there. We'll do it a couple of times and you'll get there. Right? What is this now saying? Do you get this bit? This is saying go to your f function again. Wherever x is, we're now going to replace it with minus 5. So it's going to be 6 times minus 5. But don't forget the take 5 at the end. Minus 30, take 5, we get minus 35. Done. Okay? Hello. They're the same, they're the same. Okay, we write this down. And first thing I'm going to do is say this is actually the same as f of g of x. And now it's all about the sub. What is, keep the f there, so you're keeping everything underneath. Do we know what g of x is? It is 1 minus x. And now this is stuff that we did in the first chapter where we were talking about just notation, notation, notation. What is this telling you to do? It is saying go to your f function, and wherever x is, just replace it with 1 take x. So we go to the f function, it's going to be 2 times x. But hold on, wait a minute. What am I replacing x with? 1 take x. That's the way. Finish it off. It says to go plus 3, so I finish off and I say plus 3. Huzzah, we're done. I don't want to rob you of the joy of discovering this and working it out for yourself, Sheldon, but we do need to move on. So f of g of x, we should all be able to do that. And by the way, people that have gone around and been helping with this, it is mainly their setting out that stuff them up. Okay, so nice and neat and do it underneath each other. So the first thing I would do is again rewrite this as f of g of x. And yes, I'll just write that again. Right? Now, majority of you should have already worked out the left-hand side in part A. Okay? So you should have already worked it out. I clearly haven't, so I'm going to do it as I go. So again, because I'm not dealing with this f yet, I just want to deal with what this is. What is g of x? Well, it is 2x take 3. I've just replaced it. What is this, Kane, telling us to do? Tell me. It says, where do I have to go? Which one do I have to look at? I have to look at the g1, and wherever x is, I have to replace it with x take 2. This process is not changing. It is the same every single question, and this is what I love about maths. Consistency. Rules. Consistent. So 2 times, instead of x, what is our x? X take 2. What do we have to finish with? Take 3. Okay? So what does this one tell you to do? Go to f, and wherever x is, we're going to replace it with 2x take 3. So instead of 3 times x, it's going to be 3 times 2x take 3. Don't forget the plus 5. Happy with that, girls? Equals, like this is where I will erupt. If you then in 5 minutes ask me about this one, when I'm going through and you're not listening, I'll go, grr. So now we expand 2x take 4, take 3. I'm going to tidy this up as well. 6x take 9 plus 5. I'm not going to insult your intelligence by finishing that off because it's a linear function. You've got x's on both sides. You know. You will. Correct. Get x on one side, non-x's on the other, and away we go. So I do need to move on. I'm just going to give you a couple of minutes to finish and write down what you need to. If you haven't finished the whole exercise, leave a bit of a gap, because then we're going to do sign diagrams and then you can do whatever you want to do. Leave a column to finish, and you can go back and finish those, but we just want to move on because some people have finished and they're twiddling their thumbs. Now, we write, boys at the back. Sorry, I can't wait for everybody. We just got to keep. So sign diagrams are really important. We used them last topic when? When did we use sign diagrams last topic? Sorry. When did we? Dex. Graphing, well, I wish we did. You can use it to graph and sketch functions, but we sort of skipped that a little bit because you got your graphics calculators, you could have drawn it. But we used it for our discriminant to know where we go. Year 12 and even year 11, you will use it hugely to give you information about certain things, about if a particle is moving left or right, if it's increasing, decreasing speed, if it's momentarily stationary. So it's got a lot of applications. A big application is on sketching graphs. It sort of takes it away a little bit when we've got our graphics calculators. We can just, boom, plot it in, but it's still a good skill because it helps us to do other things, all right? So, if you have a look here, where has the two, this is the question, and we have to do a sign diagram for this graph, right? So a sign diagram, number line. We draw the number line. Where have these values come from? Right, I call these critical values. So anything on your sign diagram has to be a critical value. Now, it's not just x-intercepts, because look at part B. What else have they put on the sign diagram? Asymptotes. So critical values are x-intercepts and vertical asymptotes. And please note, you must indicate if it's a vertical asymptote by going ... David, do you mind showing that you're actually listening, please? Right, again, you guys aren't idiots. Where have these signs come from? Yeah, what do you mean, the graph? We know the graph, bit more information. Above or below the x-axis. So here, left of -2, can you see all the y values are negative? Below the x-axis, hence negative. Between 2 and 1, above. Between 1 and 4, it's below, and so on. Now you go, why are we bothering? Because what will happen soon is you're not going to get the graph, you will get the equation. And I want to know, when is it above, when is it below? So guess what you'll have to work out? The x-intercepts. How do we work out x-intercepts? Factorize. That F word. Nearly said the other F. I nearly said the other F word. Right? And asymptotes. So, it starts off by just going through and doing sign diagrams for graphs. Can we say you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have to do 6 actual sign diagrams, and the other ones visualize what the sign diagram would be in your head and check the answer. If you want to do all 12, go for it. And let's just do a couple to get us started. Oops. Let's get it started in here. Run in, and run in. This is how simple this is. Our little visitors could do. So we look over here, you look at your diagram, what is our only x-intercept? We put 2 on the right-hand side, positive, negative, right? So some of these are going to be insulting. Skip those, visualize in your head, look at the answer. What about B? -1, 3. On the right side of 3, it is below the graph.
Oh, that's I see. Oh.
Between 3 and -1, it's above the x-axis, positive, negative. Mr. O, and some of you were asking last time when we did the discriminant, will it ever be plus plus? Can you look at one of these and tell me when it might be plus plus? Absolutely. D? What about E? It'll be minus minus. Why? Because it is touching, it's touching the graph. That would be a repeated root. Okay, Hames. Yep. What's this one going to be? What's on mine?
Minus plus minus. No.
Well, hang on. I need my numbers first. 0, 2.
Plus minus minus.
You're funny. So clearly, just make sure that when you get down to these ones, you must, shall we do one of these?
Yeah.
Let's do one of those. Last one. You want to do the last one? We can do the last one. It's not tricky, guys. Okay, doing L. So we start with, draw the line, and we're going from left to right. It even tells us here our asymptote is -2. So you need to put dot, 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 dot. Don't just put a dash. You have to distinguish between an asymptote and a x-intercept. So -2, and then I've got -1. Does your number line have to be to scale? Hells no. But, you know, if you've got it right underneath each other, go for it. But then it might get a bit squishy. 1, and then dot, 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 2. I'm not going to ask Hamish what the signs are going to be for obvious reasons. Plus, minus, 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 plus, plus, plus. Hells bells. Go, Matt.
Minus.
Okay, so left side. Minus. So now in between 2 and 1, it's above. Minus. Oop. Hang on, no, he could be right. Between -1 and 1, minus between 1 and plus. No alge inside. But don't be disheartened, because the alge, she's a-coming. Not yet, not yet. So, draw a sign diagram for. Now this is what we did before. We've got find your zeros. But now, how do we know if it's plus or minus? We want to pick a value beyond 1. What are we going to pick? 10. So 10 plus 3 is positive. 10 take 1, positive. So you stick a plus there. What's a number in between minus 3 and 1?
0.
0. Positive? Negative? Yeah, baby. What's the number that side of minus 6? Minus 3. Minus 10. Minus 10 plus 3, still negative. Minus 10, take 1, still negative. Negative times a negative, positively. Okay? So, nice. All factorised for you. What's coming? You're going to have to solve and factorise yourself. Now, hello. I'm about to stop, and I need you to listen to this carefully. So remember, when we've got this one, and again, I don't mind these diagrams. When is this whole thing going to equal 0? So that would be my x-intercept, my solution, my root. It will be when your numerator equals 0. Because what's 0 divided by anything? 0. So to get your root or x-intercept, we're just going to make the top line 0. Yep, 1. And there she blows. Where's this minus half come from? And it's a dotted line? Because the asymptote occurs when it's undefined, and that's when your denominator, March, you're listening to this one, you missed that with domain and range. This, you cannot divide by 0. So your denominator cannot be 0, Olivia. All right? So we're solving the top to equal 0. That will give me my root or x-intercept. You solve the denominator. When is that going to be 0? That will be your vertical asymptote. And then go through, same thing. Pick a number beyond 1. 10 take 1, positive. Positive. Boom. Okay? Rinse and repeat. Not too bad.